So in the last video we set up the SolidWorks assembly the way we wanted it for the Geneva mechanism drive part, and now we're going to go ahead and insert that SolidWorks assembly into MasterCAM and set this file up so that we can perform the machining operations. So the first thing we're going to do, I'm going to go to File, Merge. I'm going to go find my SolidWorks assembly file. In my working directory here, I have my SolidWorks assembly that we renamed in the previous video as well. I'm going to go ahead and open that. Make sure that you change your filter to all files. If you can't see it, it defaults to MasterCAM files by default. So if you want to see everything, you have to go down to the bottom and see all files. So we'll click open. I'm just going to confirm that all the parts are here. I'm not going to make my rotary moves yet. I'm just going to click OK on this. Everything looks pretty good. When we go into levels, I'm going to cycle through my visibilities to see which parts are which and rename everything. So I'll start with 6. Appears to be a parallel. 1.563 parallel. Probably means number 5 is the same. Yeah. 0.563 parallel. Number 4 is our stock block. Again, I'm putting op 10 in front of these so that if we had additional operation later on, we'd had different solids, we'd want to make sure we have that in front so we know the difference between the two. Number 3 appears to be the part itself. Yeah, so I'm just going to call that op 10 solid part for now. Number 2 is the movable jaw. Which means our number 1 must be our fixed base. Say vice base, something like that. Perfect. Okay, with all of those changed, now we can look at positioning the assembly in the proper orientation. So if I right click and look at top, you'll see that per usual the assembly is out of whack by 90 degrees. So we're seeing the front of the assembly right here. I'm going to go to dynamic. I'm going to rotate in space so I can kind of see the isometric view, and I'm going to click anywhere for the gnomon to start. I'm sorry, we need to select all the pieces first. So I'm going to do a pick box and the selection, and then here's my gnomon. So again, we want to rotate 90 degrees like this in this direction. That's between the Y and the Z axis. I'll left click on that segment, and it looks like we want a positive 90 degree move. So we'll type in 90, hit enter, check the preview, looks good. I'll hit enter again, and then OK. Again, you'll see that we need to clear colors to get the purple selection color to be removed. And now when I right click and go to top, you'll see that we now are looking at the top view correctly. Now, in order to get the WCS point where we want it, we're going to turn the stock off for a second and take a look at the part. So we do not have a sharp corner to use currently on this part in order to get the bottom left hand corner. And looking at the part, I'm not sure if what we want to do is use the bottom left hand corner. I'm going to open the blueprint up again and kind of show you what we can look at as far as datums here. So you'll notice that most of the dimensions come off of the center of the part. That is one of the most important positions, and that's because all of these are based off of the pin in the middle. So in order to make sure all of these are correctly machined, and we, when we read it, when we read the program, we want to base everything off the middle. So what I think we'll do is we'll just use the top of the part here, this hole, as our 0, 0 point. and we'll go from there. That'll be the easiest thing for us to do. So what we'd have to do on the machine is we would actually be touching off on the edges and then offsetting a certain amount, this 1.5 inches specifically, in order to get to this position and zero this out. We're going to move this to the origin. That's one of the easiest ways to do it. It's really quick. And then we'll actually be ready to go for the most part. We'll have to make a new plane afterwards. But so if we go up into transform, we have a button here called move to origin. I'm going to turn on the F9 key just so I can see where the origin is, just to confirm that it actually goes where we want it. And I'm going to click on move to origin. You'll see that it selects everything on the screen, and actually I almost made a mistake here because I turned the stock off. We want to make sure the stock is turned on before we push that button. So we're going to confirm that all of our levels are on. I'm going to click move to origin. I'm going to select the point to translate from, and that's basically the center point of the part. Now that I have this all selected, I can turn the stock back off, and I can click on the top of the part in the center of the circle here and make sure we get the center point. And then we can confirm that that is indeed where we are, and when I turn the stock block on, it also sure it came to that position as well. So that is exactly good. I'm going to hit F9 and turn that off. We're going to right click and then clear colors. So now that we have that, I'm going to go ahead and just make a copy of the top plane. The position is going to be exactly right, so all we need to do is literally duplicate this and rename it. So we'll duplicate it, rename, we'll call this op 10 G54, and then we're going to make that our plane, our active plane, so that when we start using it, it'll be on G54 here. And now we are able to go ahead and just create our stock real quick. In order to do that, we need to bring in a machine group. So since I'm working at home and I don't have the stick profiles loaded, I'm just going to use the default. I'm going to check the list anyways. Yeah, so we're in here. If we had the stick posts and everything loaded, we'd have more stuff here that we could add. But for now, I'm just going to click on default. Going to go to properties, stock setup. Going to do something a little bit different this time. So instead of doing the solid mesh selection, I'm going to use a bounding box, or bounding box. And this allows us to click on the solid. It's going to bring in our size settings and everything like that. Just going to click on that, and then I'm going to click end selection. You'll see that it made a stock profile around the outside of it. And if we wanted it to be do we want it to be a solid stock? Yeah, it turns into a solid stock after that. The only thing you need to change here is if you want to do this solid or wireframe. So I usually like to work with the solid. That works out for me. Make sure my op 10 G54 stock plane is active, and it actually looks like I misnamed this. So I'm going to go back in there and change that real quick. Yeah, I forgot to actually put the op 10 part in there. Op 10 underscore G54, that's what we want. Okay, perfect. So now I'm going to go ahead and just get rid of the solid body for now, just so I can see what it all looks like. And I'm happy with that. I just want to review the front here and see if we have stock on top, which we do. Plenty of clearance in the bottom. I'm going to right click isometric. So I'm happy with this. Our levels are all set up. Stock is all set up, and our WCS is in the correct orientation in relation to the part and to what the important dimensions are. So yeah, not too bad. At this point, we are ready to start machining this part. I'm going to go ahead and save this before we get going on that. And again, I'm going to go find my working directory, and we'll drop this in here. So for me, it's inside my week 2 folder, and I will call this op 10. Actually, we'll go Geneva mechanism drive op 10. Save. Okay. So the first thing we're going to want to do is face the part. We're going to turn the solid block back on because we're going to use that as our chaining entity. We'll turn it back off again afterwards. So we'll go to face. I'm going to make sure face is selected. I can uncheck loop too if I want to. Just click on face. Click on the top of the part. Click OK. And now we're inside of our 2D toolpath facing box here. One chain selected. For a tool, I'm going to go ahead and find my 2.5-inch face mill. You may have to use the filter to find it, depending on what library you're looking at. And you don't need to use 2.5. If you want to use 2 or 3, you can use any combination of that. Just use a realistic tool. Don't use one of these obnoxious ones down the bottom here. The comment for this face mill is going to be, the usual. So face off, I think we said 0.03 thousandths of stock to establish Z 0.0. Something like that sounds good. Feed rates and all that stuff we're going to leave the same at MasterCAM's default. Cut parameters we'll leave the same too. The default overlaps and stuff are fine. We don't want to leave any stock on the floor, so I'm going to go ahead and change that to 0. We can mess with some of this stuff later on if we want to try and make it more efficient, but for now we're good. No depth cuts. We'll cut it all in one pass. Linking parameters, we're used to these by now, so clearance of 2, retract, absolute quarter, feed plane, absolute 1/4 inch. Top of stock should be 30 thousandths. That makes sense because that's how much extra we have on the top. And then our depth should be absolute 0. I like to double check this by clicking. I will have to turn off the solid stock to do that. So if I click on the top of the part anywhere on these snap points, that should be 0. So that confirms that we're on the right plane. Everything looks good. And I'll go ahead and turn the coolant on. We'll flood it. Apply and OK. Looks good to me. We'll run a back plot on that. Don't really have any comments. It all looks good. Although I do have it one way. There's no real reason to do that. We could change it to dynamic or something along those lines. Nah, that's not what we're supposed to do. Just double check something here. Zigzag. So if you do one way, you'll see that there's some lifting. It basically only cuts one direction and it lifts up and goes back. Zigzag, you stay on the part the whole time and you're not lifting up off the part. So this tends to be a little bit faster. So I'll leave that and put that back on zigzag. There we go. The next step that I want to perform is going to be the machining of this area here, which is going to involve using a dynamic milling pass, and we're going to use the stock profile as the outside machining boundary, and then we'll use this perimeter on the inside here as the avoidance, so it machines between the end of a stock block and this here. To do that, we're going to use dynamic. And again, we need a machining region to be our stock block. That's what we want to be contained. So I'm going to turn on the solid block again. I'm going to go to machining regions, and I'm going to use the loop selection method for solids, and that will allow me to select the outside of the stock block. It correctly identified the face that I want the first time, so we'll click OK. Direction here in this case doesn't matter. We want to be able to start from the outside, right? We want to be able to machine from outside where we started. If we did this, we wouldn't get these corners machined properly. So we want to stay from outside. I'm going to turn the stock block off again so I can see the part. And now I'm going to turn our avoidance region on, and I'm going to select the same thing. We'll do a loop, get rid of the face, we'll do a loop again. and I'm going to select the bottom part of this geometry. The top would have worked too. I don't think it matters one way or the other. So basically we're telling it that we don't want to machine in this area, and we're going to machine up to the machining region section there. So those are our two chains. We're going to click OK, and we'll stick with dynamic mill. Again, our chain geometry has been selected. For our tool, we have no inside radii or anything to worry about. That's going to constrain the size of the tool that we use. So I'm going to go ahead and find a 1/2 inch or 3/4 end mill and go ahead and use that. I'm going to go use my filter. I'm going to turn on just the end mill, flat end mill filter, and we'll look. I'll use a 3/4 flat because that will rip off a lot of material nicely. So we're going to say, let's see, rough machine. We'll call that area the boss. We're going to leave stock on the walls and the floors for finish. So let's just say, let's leave 10 thousandths. Leave 10 on the wall and 10 on the floor for finish. And we'll do those two passes separately coming forward next time here. So 3/4 end mill, there's a note. We'll go down to cut parameters. We're going to leave all these on default settings for step over. We can look and see how they come out. I am going to change this to 10 thousandths instead of 50 on both of these walls and floors. We'll continue on. Depth cuts, because we're using such a large diameter end mill and we're using the dynamic tool path, we don't need depth cuts. We'll do it all at once. Entry motion we'll leave alone. We'll look and see what it looks like on the part when we do this. There's no breakthrough. Linking parameters, same numbers we always use. Clearance of 2, absolute. Feed plane should be absolute 25 for now. Our top of stock is no longer 30 because we've removed that with the facing operation. So top of stock is now 0, and our depth should be absolute. And to get that value, I'm going to click on depth and then select the bottom of that boss. So negative 0.125. Again, I'm going to go to coolant and turn the flood on, and then I'm going to click OK and see what we get for a machining profile. Looks okay from here. Let's go ahead and check this tool path here. It's a large end mill, so it's going to rip most of this material off pretty quickly. I'm going to check my front view and make sure that it makes sense that we're 10 thousandths off the top of, or off the bottom of that. Looks good. And then we should also be 10 thousandths away from the wall too when we get down to that last pass. I'm fairly confident that we're good here. Perfect. Okay, so now we need to do the finish passes on the walls and floors here. We could do that now, or we could save ourselves a tool. If we're going to use the 3/4 end mill for the outside of the part as well, we may want to do that first and then switch to whatever finishing end mill we're going to use, and then go from there using that tool without having to go back and do a tool change. So let's do the roughing on the outside first, and then we'll come back and do the finish passes for these two features. We're going to use the same dynamic mill. This time our machining region is going to be the stock block again, because we're going to be machining out to here, but just a little bit lower this time. So our machining region will be the stock block. To turn that solid on again, we'll use loop for a selection method. That looks good. We're going to do from outside again. We'll turn the stock block off. And now this time our avoidance region is going to be the very outermost part of the stock. So I can still do a loop. I'll click on the bottom of the part. Goes all the way around. We'll click OK. And now we're basically going to walk through this and do the same parameters as we did for this roughing surface here. So we'll click OK here. We'll go through it again real quick. So for a tool, we'll use that 3/4 mil again for roughing. We'll say rough the outside of the part. In this case, there is no floor to these pads, so we don't need to leave anything on the floor, but we will leave 10 thousandths on the wall for finish again. And then we'll finish the floor at depth. Holder we can skip. Cut parameters again. I'm okay with the defaults, no big deal there. We'll change that. We're just going to change this to 0 on the floor. No depth cuts because we're using a large end mill. Entry motion looked fine in the last one, so we're good there. Linking parameters all look good. The first 3 look good. Top of stock again should be 0. And this time our depth is going to be the bottom of the part here. So again, these lines will work. So in this case it's -25. We could go a little bit below that. We're going to flip this over and face the bottom of it afterwards. We could use that. We could use breakthrough for that, or we could even just use. Well, we don't want to do that. We don't want to do more. We could actually use breakthrough by a little bit and add an extra. I don't know. Let's say 10 thousandths here. That way, it just cleans down below where the part's actually going to finish. We don't want to go too deep because then we'll interfere with the chuck here. But we'll go a little bit farther than the full part depth, and we'll go cooling on again. Apply OK. And then we'll preview this toolpath too. This one we're going to want to watch where we are on the vise. And this is where it pays to have the fixturing because we can make sure we're not interfering with anything as we're machining this. But otherwise this all looks pretty good. Look at the front view again. So see, we still have plenty of clearance here. We're still cutting a little bit low the bottom. That's good. So we can also go ahead and check our solid verify just for fun to see what it looks like. And I'm going to go ahead and color loop it, and we'll hit play and just take a look and see what it looks like. Good. So we're getting there. Close that. I'm going to go ahead and save it. And now we will do our finish passes. Oops, I did save as instead. Now we'll go ahead and do our finish passes coming up here. What we're going to do is we're going to copy and paste the last couple of tool paths that we made just to make it a little bit quicker. So if we're going to do a finish pass using this on number 3, we can just highlight number 3, right click, copy, right click, paste. So number 4 is a copy of that. I'm going to go into number 4 and go to parameters because our chains are all good. That's the whole reason why we copied. Now what we're going to do is decide what we're going to have for a finish pass here. So the only thing I care about, actually we probably shouldn't have done a copy. We can do dynamic contour and see how that works. But this really could just be a contour because we don't really care about what's happening out here in this area. This is just junk. The only thing we're finishing is the wall. So really this could have been just a contour. I may just go back and change that. Let's instead of using we'll copy the next one, but for this one let's delete number 4. And I'm just going to do a basic contour instead of copy pasting that. So we'll do contour. I'm going to use loop again. I'm going to grab the bottom of that part. That's correct. We'll click OK. And now we decide what we want for a finish end mill. We'll go into tool and for the comment we'll say finish the outside perimeter. Something like that. For a finishing end mill, we'll just kind of emulate using a smaller, finer end mill for finish. I'll use the same filters. Generally, you would see, depending on what library you're in, you'd see some end mills called out as finished and some as roughing. The only difference is generally the number of flutes. So finished end mills tend to have less flutes. So you might see a 2-flute finished end mill versus a 4-flute rougher. For here, I'm going to go ahead and pick the, let's do a 1/2 inch flat, and we'll call that our finishing end mill. Reinitialize speeds and fees just to make sure. That looks good. So cut parameters here. Computer comp is fine. Compensation we'll have to look at and see which side we're on. I think left is correct. No stock to leave on floors and walls, which is good. 2D contour type is good. No depth cuts. We're going to do it all at once. Lead in and lead out we'll leave as default, which is fine. No breakthrough. And now we'll do linking parameters. So we turn the clearance on. Everything goes to absolute. Retract and feed plane are 1/4 inch again. Top of stock is now 0. And then our depth is going to be an absolute value. And it should be a 1/4 inch. We'll just double check that. Perfect. So again, make sure coolant gets turned on. Apply and OK. And then we'll backplot that toolpath and just make sure we're happy. Looks good. Okay, so now we can go ahead and do a copy paste. So now that that contour is done, we have 2 finishing passes on this top surface. So we have to do the wall and the floor. I'm going to take toolpath number 2 because that was the first dynamic toolpath that we used. I'm going to copy that. And then we'll paste that underneath number 4. So that becomes number 5. And this time all we need to do is go into these parameters and we're going to change this to the 1/2 inch flat end mill that we had. In the comment we will say rough machine the floor, or no, I'm sorry, finish machine the floor. Leave 10 on the wall. So we're going to do the 10,000ths afterwards. And then inside of cut parameters, we'll just go ahead and change the floor to 0. Everything else should stay the same. No depth cuts. We will click OK, apply and OK. And then we have to regenerate the toolpath since we just modified an existing. We'll backplot that. So we should see that this is going to machine the floor. You'll actually notice that we did cut air for the first pass, so we may actually want to change the machining region so that it is now this area here instead of the stock block, since all of this material is already gone. I think that's probably a good idea, so we'll go back in there and do that. And we'll save ourselves some time. So we'll go back into chains and we'll change our machining region to the, we'll right click on solid chain here and then hit rechain single. So we'll use loop again, but instead of using the stock block, we'll use the outside of the part since all our material is already gone. We'll hit apply and OK. OK. Regenerate that, and then we'll see this time we should be on the part right away. See that? We're not cutting air for the first pass. That looks good. I like that path a lot, so that looks great. Okay, now we're ready to contour. So no more copy pasting. Again, I'm just going to use the contour command. Make sure the red insert flag is down the bottom. We'll hit contour. We're going to use loop, and we're going to select the surface we're going to finish for the wall. So that's going to be this chain again here. And click OK. inside of contour, we're going to use that same 1/2 inch flat end mill. This time the comment will be finish the wall, finish the boss, finish the walls on the boss. Something like that sounds good. We're not calling out our final Z- value, but again, you know, I'm not really a stickler as to what we can put in the comments here for starters. We could come back and add more detail later if we needed to. So our cut parameters here, just making sure that we don't have any stock to leave on the walls or floors because we're finishing. This is good. No depth cuts, lead in. Again, I'm happy with that. We can be more specific, but there's nothing wrong with what we have now. All the way down to linking parameters. Again, all of these values should be the same. And then I want to make sure my coolant is turned on. So we'll hit apply and OK. And we will go ahead and backplot that. So as you can see, we're on the wrong side of the chain. We're cutting on the inside instead of the outside. So I'm going to go into geometry, confirm that, and we can go ahead and just right click on the chain and hit where are we? Change side. So that changes the little arrow to be pointing out, and that should change the side of the end mill that we're machining on, or the side of the side of the chain that we're machining on. There we go. That looks good. I'm going to go ahead and click Save. And that is all the tool paths for the outer areas. And now we need to focus on this inner pocket and the drilling. So this feature has some constraints because we have some radiuses that we need to make sure our tool will fit into when we're finishing. So I'm going to review the print real quick, and we'll see that the radii inside of the pocket are 0.13. So that means that our largest size that we could use to perform that machining operation would be 1/4 inch. And realistically, you want to go a little bit smaller than that because you don't want to just throw the size of the end mill in on the radius. You want to go a little bit smaller so that it actually machines the pocket and doesn't just nestle in and then pull away. So later on down the road when we finish this, we'll have to use a maybe like 3/16 end mill, I believe, to finish. But outside of that, we should be able to use a larger end mill to rough this pocket first. We'll use a 3/8 end mill to rough it, see if that looks pretty good. So rather than use pocket, I'm going to head and use dynamic again, just because that's usually the preferred method I like to do. We do have a pocket command, but it's not as clean as using dynamics. So I'll go back into dynamic mill. Our machining region this time is going to be the pocket itself. So I'll click on a loop on the bottom. And then there is not going to be any containment or anything like that. And we also want to stay inside for this feature. We don't want to move outside because that would scrap the part, right? We want to stay on the inside of these lines. So we'll click OK. We'll check dynamic and see what that looks like first and see if we like the profile that we get. So as I mentioned, for a tool, maybe we'll use a 3/8 to start and see if that looks good or if we can go even bigger than that. But for now, we'll start with 3/8. We're going to say rough machine pocket, and we're going to leave 10,000s on the floor and walls for finish, just like we did before. So leave 10,000s for floor and wall. Leave 10,000s on floor and wall, on floors and walls. There we go. Floors and walls. For finish. And again, we use those independently because we want the cut direction, the cut force to be equal. So we don't want to be cutting on the wall and the floor at the same time. We just get better surface finishes and better tolerances if we do them separately. So again, 3/8 flat for now. Cut parameters we'll leave alone again. And we'll just make sure that we leave stock on the walls and the floors. So 10 thousandths. We can look at this later. Depth cuts we don't want to use. We actually want to, we want our entry motion to go all the way down. It'll spiral down to full depth, and then it will start to dynamic out. This radius we may have to reduce a little bit, but we'll check it out and see what it looks like. Again, the smaller this number, the more stress you put on your machine, because it's making little tiny moves to get in here. So the larger you can leave this, the better off you are for the machine. And then the plunge angle is actually how aggressive it's cutting in the material at first point. So again, I want to see what it looks like before we start messing with that. Linking parameters, these values all look good. Our top of stock should be 0 again. Our depth we're going to check out and make sure we have the right depth. So -1/8 is correct. We'll turn the coolant on, and then I just want to go ahead and backplot this and see what we get. Okay, so 3/8 is probably way too big. We'll have to go a little bit smaller. I do like the motion that the tool was making though. Looks pretty clean. I don't know, maybe we'll leave that there. I think that's actually not that bad. I wouldn't want to go any bigger than this. No, I say that's good. I think we're going to leave that actually. Perfect. Just checking to make sure that all of everything's all lined up. I'm happy with that. At this point, I'm actually going to turn my stock display off because it's really not doing anything for us. We know where it is, and we've already got most of it machined out. So that's the roughing. So now let's go ahead and finish with our smaller end mills so we can get the walls done. We'll do the floor first, then we'll do the walls. I'm not going to bother copy pasting because it doesn't really add much to this. Well, actually, for the floors, we might as well because it's easy to copy that. So we'll go copy, and then we'll paste. Go into number 8, and we'll go into parameters. So there's only 2 things we should have to change here, right? So we're going to use a smaller tool for finishing. I'm going to go and find my 3/16 flat, and we'll use that to finish the floors as well. So we'll use that to finish both the floors and the walls. I want to reinitialize our speeds and feeds and make sure that gets adjusted properly, so that did get changed. I haven't been very diligent about that. Usually you do want to reinitialize your speeds when you change end mills. Our comment here is going to be finish machine, and then we're still going to leave 10 thousandths on the, so we'll just say finish machine pocket floor, leave 10 thousandths for wall finishing. So that's good. Cut parameters is where we want to change that, so we'll change the floors to 0, leave the walls at 10, double check our linking parameters, and then we're going to go ahead and make sure our coolant's still on. We'll apply OK, regenerate that, and then we'll go ahead and watch. So we're air cutting right here, right? So we can probably adjust that a little bit. We could actually change our feed plane so that we're not cutting that. Or the other thing we could do is actually change the way the lead in and lead out looks. Okay. Let's go and think about this for a second. So our entry motion, instead of helix, we can just come straight down. That's one way of saving some of this because we're not entering into material, so all we need to do is come straight down, plunge to our endpoint, and then inside of linking parameters, so our feed plane is absolute 1/4. In this case, we can start getting a little cute, so maybe we change the feed plane to 0. So that would be here. And then, so it's going to wrap it a little bit lower, and then it's going to feed down at speed, or at our cutting speed. So see, that cleaned the path a little bit up. So the tool actually starts at 0 here. It's plunging straight down, and now it's finishing the floor. That looks pretty good. I like that, actually. That's a lot better, right? That's a big difference. Yeah, I like that a lot. So since we're only finishing 10,000ths off the wall, we could actually change this too. So you see this is step over here. It's not very aggressive. There's no reason to be that soft with it because we're only taking 10,000. So now we can go in here and actually start tweaking things. So that's inside of cut parameters, and our step over distance is what this is. So 25% of the tool width is only 40,000, so that's barely anything. I'm going to crank this up to 75%, so that's just over 1/8 of an inch, and we can see what that does. So see, that reduces the amount of motion in the tool and the runtime by quite a bit. And there's nothing wrong with that because, again, we're just machining 10,000ths off the bottom, so we don't need to be that stingy with the cut time. I think that's pretty good. I like that a lot. Okay, so we'll leave that the way it is, and now we're going to go ahead and finish contour the outside of this pocket. I'm just going to use a regular contour command. We're going to loop that profile again. Getting used to this, going pretty fast. So again, we need to use the 3/16 end mill so that we make sure that we are able to machine that full radius without leaving any stock due to the end mill being too small, or too large, I'm sorry. The comment for this will be finish the pocket walls. 3/16 flat end mill again. Cut parameters, just make sure we have 0 and 0 here. We'll have to check and see what side we're cutting on afterwards. No depth cuts, lead in and lead out will be the same. Linking parameters, we'll leave these at 1/4 inch again for now. We'll take a look at it. Top of stock is 0, and we'll just confirm that depth is -1/8, which is good. Make sure our coolant is on. It is. Apply and OK. And then let's just go ahead and watch what this toolpath does and see if we like it. Again, we're starting up higher than we need to, so we're starting in the middle of this radius, which is fine. Rolling around there, which is good. Yeah, I'm very happy with this. I don't think we need to change anything on this. Rolls out, pulls up. Perfect. Okay, excellent. So now at this point we're done with all of our milling operations, and we can move on to the drilling and reaming. So we're going to start with the spot drills first. I'm going to go ahead and turn the tool paths off so it's just easier to review this. And we are going to check the printout and see what we got. So we got 2 1/8 inch holes that are +4 -1, which is pushing it for a drill. I'm going to go ahead and drill these for now, but this actually is pretty close to ream tolerances. Normally it's like +7 for a drill. It's not the most accurate tool to use for this. We could also end mill these. I mean, well, we could plunge mill these with a center cutting end mill. For what we're doing though, we'll try drilling for now. We'll do that. These tolerances here, the 253, 251, and this one here, the 5/10, these are definitely going to be reamed holes. This one we may actually even have to mill. Think about that for a minute. I will probably ream both. We're going to have to make some tools or just change a couple of existing tools to make these sizes, because these obviously are non-standard sizes. So we'll start with the 2 1/8 inch holes though. I'm going to spot drill these separately, because I do want to break the edges on the top. These will be easy because they're exactly the same. These are pretty close, 250 and 253, so we can spot drill these at the same time as well, and just go a little bit bigger so that the edges are broken on the top. They don't call it out, but I know we're inserting a dowel into this pin, for example, so if we did this with a sharp edge, it'd be hard to get in there straight, so we do want to break the edge on top a little bit. Okay, so as I mentioned, these are going to be an 1/8 inch drill. Let's go ahead and go up to our drilling command. And as I said, we're going to spot drill first. So I'm going to select the center points of the 2 1/4 inch holes. If we weren't worried about breaking the edges, I would probably do all 4 at once. But since we are doing this way, I'm going to do them with just these 2 instead of the 4 holes. Click OK. Inside the tool, we're going to have to go into our library, and we're going to have to find a spot drill. So I'll go ahead and use the filter to get all of our spot drills, which should be, there it is. So it is on the 3rd row down here, almost close to the edge of the on the right hand side. So spot drill, and we want to use something a little bit bigger than the size, right? So if we're going to go a little bit bigger, we need to use at least a 3/8. So we'll use a 3/8 spot drill, and we'll say spot the 0.25 holes, and we'll actually go to 0.26 to 0.26 diameter. So that means there'll be 100 thousandths break edge or 50 thousandths on the side chamfer on the top of those holes if we do it that way. Cut parameters, drill counter bore is fine. Linking parameters, we need to reset these. So clearance should be 2 absolute. Retract should be 0.25 absolute. Top of stock is still 0. Now our regular depth should be at 0, right? So we're going to start at 0, but then we're going to use the calculator to figure out what we need to go to a depth. So if we want our finished diameter to be 0.26 based on a 90-degree angle, we can see that our depth needs to be -0.13. So we want to overwrite that. That should be our total final depth. And then I'm going to turn our coolant on while we're doing that as well. So we'll go apply OK, and we'll preview that. And what we should see is the spot drill going a little bit deeper than it actually needs to. And that is what we want to see, because we want to break the top of the edge here. Perfect. Actually, that's a little bit too deep. We're going to change that. Yeah, that's true, because that's a small hole, so 100,000 is definitely way too big. So let's go change our note first. So let's go to 2 point, let's see. Well, 10,000 shouldn't have been that much. Let's go 255. So we'll have 5 thousandths breakage on the top of that. Let's see what that looks like. So we'll go back to depth here. I'm sorry, we'll go with the calculator. So our finish timer should be 255. That's still gonna be pretty deep. These are small holes, so yeah, that's still too much. You know, I want to check something here. I'm going to go into my SolidWorks model and just confirm the dimensions on this. So if I go to measure these, yeah, they're 1/8 of an inch. Okay. Go back into parameters and the drill. And let's make sure I'm not missing anything here. So cut parameters is good. There's no tip comp on this. Now let's go to depth of 0 and see what it looks like. It shouldn't cut anything at this point if we do it like this. So it's going to stop right on top of the hole. Yeah. Okay. It just looks too deep to me. Let's just do 2.5 for now. Finish diameter 0.25. So depth should be negative 1.25. And then let's see what that looks like. I think it's still going to be too deep though. If this is correct, then the drill should end up stopping when it gets here. Nope, see, it's going too deep. There's something else going on here. Let's just see if I can find it here. Oh, it's an 1/8 of an inch hole instead of a 1/4 of an inch. Oh my god. 1.25. So it should be 1.3. Spot the 0.125 hole to 0.13. Linking parameters, calculator, 0.125. It's 12.15, so that's, you can tell I'm starting to lose it here. So now when we do this, our depth, that makes more sense. So 0.125 is our 0.13 is going to be our finished diameter. So our depth should be negative 0.065. That makes more sense. Apply and OK. Now when we run this thing, it's going to look better than that. Okay. There we go. That's perfect. Okay, beautiful. Now I just thought of something. So we're going to have different Z depths here. So I probably won't spot drill these in the same command, but we can just copy paste. So let's go ahead and spot these now. We can use the same 3/8 spot. So I'm just going to go to drill. I'm going to go ahead and just do this top one first. Say spot drill center reamed hole to 0.26. So this is actually a 1/4 inch, right? Yeah, 0.25. So this one will go to 0.26. 3/8 spot drill again. Linking parameters, we got all our settings here. Top of stock goes back to 0. And our depth is going to be 0, but our finished diameter is not 0.26. So 0.13 is our depth. Check our coolant. Apply and OK. We'll backplot that one. That's good. Now I will copy paste this one. Actually, let's save this first before we do too much more work without saving. So save. Okay, so let's copy number 11. We'll paste it. We do need to change the geometry on this one. So I'm going to delete the first one and reselect this one down here. And then we're going to go into parameters. We're going to go to, I think, just linking parameters. We're all set with all that stuff. Top of stock. So really our top of stock for this hole is a little bit lower because we're at a different level. So we could actually change our top of stock to this level here. So negative 1/8 of an inch at that point. Our depth, as a base is also going to be a -1/8 of an inch. So we want to start that. We want to add that as our baseline. And now when we go into the calculator, this is where we use add to depth instead of overwrite. So if we want to use 0.26, we want to add another 1/8 of an inch to the Z position here in order to get to that. So -255 is our final absolute depth. So we'll click apply and OK. We'll regenerate that command, and then we'll see what that looks like. That's too deep, actually. Did something there. I think that's too deep anyways. Maybe not. No, that's correct. Good. So all of our spot drills are complete. I'll save this again. And now we can just quickly walk through the reaming and drilling command, and we can finish off this tutorial. So we're going to go ahead and peck drill these 2 1/4" holes or 1/8" holes to start. We're going to go to drill. I'm just going to reselect these 2 features here. Click OK. We got to go into our tools and find our 1/8" drill. So I'm going to go ahead and change my filters again. And we want a drill, which is right there, second row. And again, we're looking for 0.125 1/8" drill. Perfect. Again, you know, I may have to review that and see if we would use a reamer for this. It's close. I would probably use a reamer, but well, for now, it's getting late, so I want to get this thing wrapped up. So 1/8 of an inch drill. The comment will be drill the 125 holes. We want a peck drill because the size of the drill is small in relation to the depth that we're going. We're going a 1/4 inch, I think. We got an 1/8" end mill, so let's peck at 100 thou. So at least we'll get 2 or 3 pecks as we're doing this. Linking parameters should all be good. Our depth is going to be the bottom of the part, so we'll go ahead and rotate this around and grab the bottom. 1/4 inch. We're not going to add any extra length here. We're going to do that in tip comp. So we'll turn tip comp on. So additional breakthrough of 10 thousandths is good. And then this calculates the tip angle that we need automatically. So that's good as well. Coolant will stay on. Excuse me. So we will click OK. And let's go ahead and just watch that peck drill cycle. I think our top of stock is too high. We should go in there and change that. So let's go to inside the peck drill, linking parameters, and yeah, our top of stock was still set to 0. So we'll change that to 3. So we'll change that back to 0. We'll regenerate that, and then we will preview it. It's still a little bit too high. So at this point, maybe we change the retract as well, or not the retract, but the feed plane. We can reduce that. Oh no. No, we'll leave it alone. We're fine there. Now we can look at our last 2 features. So we'll start with the center hole. Again, that's 0.251 to 253. We'll just put the 1/4 inch reamer in there for now. We're going to go up to drill. I'm going to select that feature. Make sure you get in the center again. Click OK. And this time we're going to ream, but we're still going to use the drilling command. We're going to go into Tool, and we're going to go into the library and find our reamer. So I'll go into the filters. And our reamers are, this is kind of a hard one to find. There we go. Second row all the way to the right. We have a 1/4 inch ream. We're going to use that for the center for sure. And maybe even just use that for this one too. We'll ream both just to make it easy for now. Maybe in class we'll talk about those tolerances and we can discuss what maybe we do differently. But for now, let's do ream the center hole. We're going to go to cut parameters and see if there's a cycle in here for reaming. Now on the default there isn't, so we'll leave it as drill counter bore for now, but I will add a dwell. So I always forget what the increment is on this. I think it's in seconds. We want to let the reamer sit in the hole for a little while so it forms. The more rotations you get inside of the hole, the better formed or the more cylindrical it will be. So we want to let it sit there for a little while at depth. Linking parameters. So we're going to again change the depth to the bottom of the hole, but then we're going to go even farther. So we'll have tip comp turned on. The reamer's flat, so it's not calculating a K value, but let's go ahead and put like 0.125 for a breakthrough amount. So we're down past the bottom quite a bit. We may even go farther than that depending on how it looks. For this we'll turn the coolant off, because a lot of times you actually put oil or something on that for a ream instead of the coolant. So let's back plot this, see what it looks like. I want to make sure we get past the lead on the reamer, so that looks pretty good. And again, we have to review the dwell time on that, but for now we'll leave it at 1. And I'm just going to copy paste this and do the same thing for the other hole, just to keep it simple. So we'll copy and paste. And all I'm going to do is change the geometry. So we're going to delete that first one and reselect this hole here. Make sure we get the center. And then we got to change our depths inside of the parameters and the note as well. So this tool note is going to be ream we'll call this one the pinhole. Cut parameters stay the same. So this time we're going to change top of stock should be 0. So our depth should be, actually the depth is the same, -1/4 inch. It'll start a little bit higher. We could change our top of stock to the top of the hole, bring it in a little bit closer at the start. Tip comp stays on, everything else stays the same. And we regenerated, that's right. There we go. So we should have the same breakthrough amount on that, which looks pretty good. So again, just we're cutting corners here a little bit, but that looks pretty good. Okay. The last thing that I want to do for this file, I'm going to save it, is we're going to flip the part over and machine the remaining material off. So to do that, we're going to make a new plane, and I'm also going to go ahead and turn all the fixturing off just so it's out of the way. We're going to make a new toolpath group. So I'm going to highlight machine group 1 by left clicking on it. I'm going to right click, go to groups, and do new new toolpath group. So this is going to be op 20, and I actually failed to rename the first one. So this first toolpath group should be op 10. We should have done that first thing. Good. So I'm going to turn our fixturing and stuff off, and the only thing I'm going to leave on is the part for now, just to make it simple. So I'm going to flip this over, and I'm going to make a new plane, and we're going to put it in the central hole again here, just like the last side. I'm going to go to planes, create new plane from solid face. I'm going to select the bottom of the part, That orientation looks fine. Z positive is good. Doesn't really matter where X and Y is pointing in this case, because the feature we're going to pick is symmetrical. You know, it's in the center of the part, so X and Y would be the same no matter what we do. So plane 1 of 8 is good. And the origin point is actually good by default too, because it grabbed the center. We'll probably double check that. I'm just going to click OK. I'll rename this to op20 G55. Oops. op20 G55. And I'm going to use the cursor in the bottom left hand corner just to make sure that I do indeed have the right selection there. And yeah, 0, 0, and the Z origin's a quarter, so that's perfect. I'm going to make the op20 plane. I'm going to make sure that that is selected before we make a toolpath command. And I'm going to go ahead and turn the stock back on at this point because we're going to use that for our facing command. So again, op20, make sure the red insert flag is under op20. I'm going to go to dynamic. My machining region is, I'm sorry, not dynamic, facing. I'm going to go to face. I'm going to use the face selection method to pick the bottom of the stock. I'm going to go in and turn. I'm going to have to go back out after this. I'm going to go into Tool and reselect our 2.5 inch face mill, and the comment for this will be to face the remaining stock off of the bottom. I'm going to reinitialize speeds and feeds. So cut parameters, no stock, leave everything else by default, no depth cuts. Linking parameters, so these should all be good. Our top of stock is going to be whatever the remainder is, right? So it could be 0.22. We have the math on that, or we just click on it, so that's fine. Our depth should be 0 because we're going to the basically the origin point of the plane that we just created. And then coolant should be on. Apply and OK. I'm going to turn our stock off. It looks like maybe we should probably do a depth cut on this. 1/4 inch is probably rather aggressive. Yeah, there's still plenty of material to remove there. So I'm going to go and we will do depth cuts here. So let's do depth cuts max of 100 thousandths. So that probably means we're going to with 3 passes. So there's number 1. There's number 2. Yeah, 3 and 4. Perfect. Okay. Now again, you know, because we're only facing the bottom, it's not worth doing a new fixturing setup and all that stuff for this. So I'm happy with this. I am going to go ahead and select the entire machine group, and let's go ahead and do a verify and just simulate the entire part. I'm going to put the insert flag up top here and make the first plane. Let's turn all this stuff back on. I'm going to make the op10 G54 plane active. We'll look at it this way. And I'll turn the stock model off. And then I'll save it. And then we can do the verify real quick and see what that looks like. So we make sure all of these are selected. Verify. And now we're going to go ahead and we'll let it run and see what it looks like. So far I'm happy with it. Looks good. Good, great. So there's our finished part. So at this point we could use the the simulate, verify the comparator and check for tolerancing and things like that. Probably go over that in class next time. But for now, this is the end of this. So once you get to this point, if your part looks just like we just reviewed, you're all set. You can go ahead and submit it, and hopefully we won't have another snow day next week on Monday. I think we're supposed to get more snow, so we'll see what happens though. So have a good night, and I will see you next week. Thanks.